Hello friends, welcome to Control Theory lecture series. I am Tunde Emmanuel. This lecture is open loop and closed loop control systems. In today's lecture, we'll be looking at overview of control problem, concepts of open loop and closed loop control, transfer function analysis of feedback control system. The definition of control problem. The control problem may be stated as follows. A physical system is to be accurately controlled. The system's response or output is measured and adjusted based on error signal. The error signal is a measure of the difference between system's measured response and desired response. A controller is required to process the error signal and actuate the plant to comply with predefined control criteria. These control criteria may include disturbance rejection, steady-state error reduction, transient response, sensitivity to parameter variation. Now, solving the control problem will involve 1. Choosing measurement sensor appropriately, developing models for systems components, which components may include the plant, actuator, sensor, and so on. Designing controllers based on models and criteria. Analytical evaluation of the design, control design. And finally, iteration of design procedure until satisfactory response is obtained. This defines the problem and how to obtain solutions to the problem. Now let's look at the comparison between open loop control scheme and closed loop control. Open loop control entails using the understanding of the dynamics of a system, a physical system, to enact a suitable control law in order to realize a desirable system response. In open loop control, there is no measurement of the state or the output of the system. The dynamics of the system is reverse engineered, and on the basis of the understanding of these dynamics, a control law is enacted to drive the system. In the event of disturbance, the system produces error, and the scheme is not robust to disturbances, external disturbances, even internal disturbances. It involves high energy expenditure. On the other hand, the closed loop or feedback control scheme entails sensor measurement of the system behavior or state, and based on this measurement, a control law is applied to manipulate the system in order to give a desirable response. Now, here is a block diagram of closed loop control system. We have our plant, P, we have our controller, we have our sensor, and we have a reference input, which is our desired response. This is set and predetermined for the system. Then, with the measurement of the state or output of this plant through a sensor, then that is compared with our desired response, which is a reference input. Then when there is a departure between the measured output and the reference input, an error signal is produced, and that error signal is used by the controller to produce an actuating signal that will drive the plant appropriately so that a desirable output can be produced. And the process continues on the error until the error signal is nullified. Now, what is the goal? What are the goals of feedback control? First one is to compensate for model uncertainty in the event of disturbances, internal disturbances, parameter variations, or model variables of the plant or the system or the process. the feedback control enables us to compensate for such uncertainty, to correct system unstable condition, to reject disturbances in the system, especially external uncertainties, disturbances that come as a result of the environmental changes, and to achieve energy efficiency. Now, suppose we have a feedback control system with a disturbance input introduced here. Now, we can analyze the system using a transfer function analysis and observe the effect of the control law on the reference input and the disturbance. And this is as follows. This is our block diagram, and we assume that our sensor is a unity feedback system. Our system is a unity feedback system which measure the whole, is a full state feedback, measures the entire state of the system. Now, the actuating control signal U, which is the output of our controller K, gives an output K multiplied by E, that is K times E error signal. Then the error signal itself is E equals to the reference input minus just a minute, the reference input minus the measured output Y. Measured output Y. Then U of K. U equals K, where E is equal to R minus Y. Then we substitute for E, the error signal here, R minus Y. Then we open the bracket. So we multiply K by R and K by Y, so that we have KR minus KY. And next, we look at the system response or output, which is given by Y. So Y is equal to PU plus D. So let's look at our system again. PU plus D, the output of the plant is P multiplied by U, then which is now the input to this comparator plus the input, disturbance input. That makes Y. So Y is equal to D plus P multiplied by U. Then, since we know the value of U, which is KR plus KY, as earlier in the previous slide, we obtained the value of U to be KR plus KY. Then we substitute. Then we open our bracket. Y is equal to PKR minus PKY plus D. Then the simple algebra is carried out, and we obtain Y to be equals to PK over 1 plus PK multiplied by R, which is the reference input, plus 1 over 1 plus PK multiplied by D, which is the disturbance. Now, what is the significance of this result? Y is equal to PK over 1 plus PK multiplied by R plus 1 over 1 plus PK multiplied by D. It can be observed that the control system is tracking the reference R, because as K, which is the control gain, increases, PK over 1 plus PK tends to 1. In other words, this whole coefficient here goes to 1, so that Y is tending to R. So Y, the output, is tracking the reference. Then, in this case, we have 1 over 1 plus PK as K increases. As K increases, 1 over 1 plus PK tends to 0, and D tends to 0. That means the disturbance, D, is being rejected. So the control system is rejecting the disturbance because this coefficient here goes to 0 and D is rejected. D goes to 0. this coefficient here goes to 1 and y tends to r. So we have for this, y tending to r means that the output is tracking the reference, is following the reference. For this, d tending to 0 is that the control system is rejecting the disturbance. In summary, attempt has been made at explaining basic concepts of open loop and closed loop control, as well as overview of control problem and the transfer function analysis of feedback control system. I hope these concepts and this explanation are now clear to you. Please send in your questions through the comment section below. In order to be notified when the next lecture video is posted online, please do subscribe to my channel by clicking the subscribe button and notification bell below. Thank you.